In this video, we're going to review some of the conventions about naming compounds. So this video has three sections: naming compounds that are metal, non-metal, and I would say that these focus on elements. And our next section will be a metal or non-metal, but using a polyatomic ion. So the last thing we'll talk about is naming with transition metals. So the rules for how we name compounds when it's a metal, non-metal are true no matter whether it is with a polyatomic ion or a transition metal. So we always write them with the metal first, followed by the non-metal. And so if we were to look at the example of this compound, MgCl2, now this is the subscript here, and we know that the chlorine ion has a minus charge. We know that magnesium has a 2+ charge, so therefore we need two of these to give us the chemical formula, MgCl2. And so when we name this compound, the first name is the metal, which is magnesium, and it's followed by the non-metal element with the name changed to be IDE. So this would be magnesium chloride. So Cl is chlorine, and we're going to remove this part and make it into IDE. So the metals keep their regular name, whatever the element is on the on the periodic table. The non-metals get changed into IDE. So that would be nitride, oxide, sulfide, chloride, bromide. And those elements tend to end with something else. And so if we think about this, what would it look like if we named something else? So in this case, I want to have calcium. And with it, I would like to add oxygen. So we have calcium, and then we have oxygen. So the charges on these two are a 2+ and a 2-. So the chemical formula is CaO. So we know that calcium keeps its own name, Cal, calcium. And then oxygen loses the gen and adds an ide, so it's oxide. It also loses this Y. And so we can look at them in this way. And so as a reminder, if I give you the name of a compound, so let's think about aluminum. And it's going to be combined with sulfide. So we know that aluminum is Al, and sulfide is really sulfur, and that's S. So the charges on these are 2- and 3+. So this compound would be Al2S3. So we should be able to transfer either way of these. But when we name them, it is the metal followed by the non-metal. And so this is just for the elements. So what happens if we start to think about something with a polyatomic? So polyatomics are things like NO3-, which is nitrate, sulfate, which is SO4 2-, ammonium, which is NH4+, and so you need to know the chemical formula and the charge. The charge tells you what the charge is on that. So just the way that we know that oxygen is a 2-, we can also know that the sulfate is also a 2-. So that's where that information is. So when we name them, if it is a metal with a polyatomic ion, it is just the metal and the polyatomic ion. For example, if we have NaNO3 as the chemical formula, we know that Na is sodium and the NO3 is nitrate. And so they just keep the name that they have on the polyatomic sheet. And so we can set those up. And so when it becomes more complicated would be if we were to have ammonium sulfate. So this has two polyatomics. When we want to write the chemical formula, we need to know the charges on both of these compounds so that we can figure out what the balance is. So ammonium is NH4 plus, and sulfate is SO4 2 minus. In order to balance out the 2 minus charge, we're going to need two of these. So the chemical formula would be NH4 parentheses 2 SO4, because the charge on the sulfate is a -2 and the charge on the ammonium is just a +1. So both of those come together. So the polyatomics keep their name. When it becomes complicated is when we want to go from the name to the formula. So if we have magnesium phosphate, we know that the magnesium is Mg2 plus and the phosphate is PO4 3 minus. So we know that those charges don't balance out. So we're going to need three magnesium and two phosphates in order to balance those out. So we would end up with a -6 after our two phosphates and a +6 with our three magnesiums. But the names are just the names of the polyatomic ions. So transition metals. The transition metals, when we look at our periodic table, are our friends right here. So the transition metals can occupy multiple states. So these metals So what do I mean by that? Because saying they can occupy multiple states, do I mean that they could be like a solid and a liquid? Those are states. What I mean is they can have different charge states. So we know that oxygen can only be a -2. That's it. But a transition metal could be something else. So if we look at iron, which is Fe, iron could be either 2 plus, Fe3 plus, it could be Fe1 plus. So we need a way how to determine what that is without having to do other information. So we can annotate those by writing them out as iron 2, and then the name, chloride, or iron 3, chloride. So in both of these, we know that the counter ion is chlorine. So we have Cl- for both. But these numbers here, which I'm going to highlight in red, these don't tell you how many there are. They tell you what the charge is. So these are the charges. So that means that we know for the first one, we have Fe2 plus, and for the second one, we have Fe3 plus. So once we know the charge, we can use the same conventions that we learned before to determine that the first one should be FeCl2 and FeCl3. Those are both iron chlorides. They just have different, what we'll learn in later chapters is called an oxidation state. And so how we figure that out is complicated. So naming is tricky. Naming with transition metals is even more complicated. And the reason it is complicated is because they don't follow the rules. So if I gave you cobalt 2 oxide, you need to remember that oxide is oxygen, so that would be O2 minus. And this right here tells you that it's cobalt 2 plus. Therefore, your chemical formula is COO. CO for cobalt, for oxygen. So this Roman numeral tells you the charge. So it can go forwards and backwards. And so if we were to look at AgNO3, 2. So we need to figure out what the name is. We know that Ag is silver, and we know that the NO3 is nitrate. But what is the charge on the silver? So we can use our context clues. So we know that the nitrate is NO3 minus, and we have 2 of those. Therefore, the silver has to be Ag2 plus. And so we do that by adding it in here. There are some elements on the periodic table, and ironically enough, silver is one of them, that can only have one state. Technically, silver can only be silver 1. But for the purposes of this class, we are going to violate those rules and name all of our transition metals using the Roman numeral convention. So the ones that are always the same, so silver is always a +1, zinc is always a +2, and there are a handful of other ones. But in terms of my course, we can set them up this way. So the other day in class, I used vanadium 2 chloride. And so many of you were able to determine that it was V and Cl. But we didn't know where the transcript went. So we know that chloride is Cl minus, and the question becomes, what does the vanadium equal? So some students were like, hey, I thought this 2 meant that there were 2 of them. It means that there are 2 charges on it. So 2 plus the Cl minus tells me that it should be VCl2, so that the 2 negative charges cancel out the 2 positive charges. The Roman numerals just tell you what the charge state is. So as long as you know what the other one is, you can back calculate this. And so you might need to remind yourself of the transition metals. I will never give you 2 compounds that both have variable states together. One would be unknown and one would be known, or 2 would be known.